So I've reset my hardware info clock and I'm currently installing a game. Currently installing a game on Epic, and while we're doing that, we're just browsing. So I'm on the Intel page and the document is still deleted or removed or taken down for editing, or I think if I had to take an educated guess, perhaps they're going to revise it so it's more accurate or something. But yeah, let's use the Wayback Machine as suggested by some individuals in the comments. I have actually used it already, and I have checked out the document page again. So if I paste this in, there should be a copy for us to look at. So we can go to 2023 and we can find one from the state. I believe this does work. And I'd like you to notice while we're doing the game download, while browsing, I also have IQ open, I have Afterburn open, I have some other applications open. And I would like you to notice that it seems as though our 5.8 boosts have substantially slowed down, decreased in frequency. It seems as though the cores are more reluctant, less likely to boost to 5.8 now that we're handling a few applications and leveraging a few more cores. I'm not sure what the threshold is exactly, how Intel have used it, but at least from what I've seen, it doesn't seem as though these chips are all too willing to boost to their max frequencies under substantial loads. At least in all my testing and all my observations, I've never seen happen. Now, I do think it can happen if you do mess with the TVB settings and enable stuff like IABT. In that regard, you probably can, but that's going to be on you because those are not necessarily default settings, right? So if I scroll down right now, we're drawing around 30 watts. We had a max of 130. Not too sure where 130 came from. Obviously, we've been monitoring for 3 minutes now while the video's been recording. So not too sure where this 130 happened, but it seems as though loading things and doing other tasks simultaneously, perhaps some of the shader compilation happening, if that app, or not shader compilation rather, but file unpacking or whatever's happening right now with Epic, it is adding to the CPU's core load. And we can quite clearly see it's reluctant to boost to 5.8. It doesn't want to. Doesn't want to. 5.5 is all the way through. I do see 5.8 sometimes, but it's only on desktop. And usually when I'm doing something very mundane, never even something like installing a video game or compiling a shader or anything like that. So there was some pushback in the comments in the last video regarding the document. I have it here now. During the video, I didn't have it. Obviously, if I had access to it, I would have looked at it. I didn't think of using the Wayback Machine. I wasn't sure it would actually have a notch-out copy of this document because honestly, I've never used it before. To this point, I've never really had to use the Wayback Machine. I've never really had to look for something that was, old. I didn't. Well, I thought you could use it for like random web pages, but I didn't think you could use it for something like this, something like a document, a PDF. So that's new to me. take that as you like, but I wasn't sure you could use something like this to actually find null document. And if you do look at a few of the other instances, if I show you, there are actually a few more recent instances, and I believe Intel have actually. I'm not sure if they've been blocked or what exactly, but if you look at maybe this one. So May 3rd. I believe this document was still up on May 3rd, so let's see if there's a May 3rd copy right here. And there is, okay. Okay. So let's type in 253 and should be able to get to the page we want to get to right here. All right, so I was talking about the PL1 and PL2 being matched and that potentially being an issue. And as you can see for the KS SKU, which is the 150 watt pot, it is actually matched on the regular config right here. So for the 3900 KS and the 1400 KS, which are both 150 watt base spec pots, in this document right here, the PL1 and PL2 for the CPU is still matched. So this would be a 1300 KS if you have one. And the extreme config obviously has it as 320. And it's 320 both ways. But as you can see, the base config is still 253, 253. For the non-KS SKUs, so for 1300K, KF, for example, and I suppose the 1400K and KF, you have 8 plus 16, 125 watt pot, which is, again, those two examples. And then you have the regular config seems to be 125 PL1, which is in line with the product page. So that does line up. The extreme config is 253, 253. But as you can see, oh, actually, I can't show you right here, but you saw it in the previous video that my baseline profile that I had loaded had these two values at 253 on both, right? And that is Asus. Now Gigabyte, because I have seen this on Gigabyte boards too, because I have been on a few Gigabyte boards over the last few months. With Intel, I have loaded defaults on a few Gigabyte boards. I have done the same on a few MSI boards. I've done the same on ASRock boards. Are there any other vendors? BioStar I haven't worked on. I don't believe ever. And EVJ obviously, I haven't worked on an EVJ board in how long. I have no idea what EVJ board's doing. I really couldn't tell you what the EVJ board settings are like. But yes, so I wanted to search up 1300 case, right? And we can do the same for the 14 case. I don't believe. Let's do this 1400 KS 320 watts. I don't believe that. I don't believe this chip is. Oh no, it is. I don't know if it is. I'm not sure if this is actually a 320 watt pot because I know the 13 KS was, but I'm not sure this one was. Okay, this one is as well. Okay, so this extreme profile is right. This is what we're looking at right here. Sorry, let me find that for you guys again. This would be the extreme profile they're mentioning, and the same thing for the KS 39. So if I do 320 watts, and you will see they mention it a few times on some articles. Here we go. Yeah, so the extreme profile for these chips is still 320, but the base profile is not. So if I go find the yes, and so the extreme profile you guys notice there is 320, right? But notice how the base profile is still 150, 253. And the base profile for the 150 watt CPU, which is these two CPUs, are the 150 watt pots that this documentation is referring to. So these two CPUs, and for some reason the product page still does not line up with their base profile, with their non-extreme config, right? So there was not so much pushback, but especially one individual was taking issue with me with how I was with what I was saying. Now, what I want to make clear, guys, is that when I make my videos, especially when they're regarding Intel and the degradation, the only thing I'm very firm on is the fact that it is electromigration, and it's deductive, yes, but I think it's logical because if it was oxide breakdown, now I don't know if you guys have, but I watched a video by Buildzoid from a few years ago where he took a older CPU and simulated oxide breakdown, and what happened was the CPU seemed to really not mind until he got to a certain point, and at a certain point, the CPU just flat out shut down and did not turn back on. And from my understanding, oxide breakdown is quite a abrupt and dramatic death of the CPU. Uh, it at least from everything I've read and from what I understand, it isn't something that happens over time. You need quite drastic voltages to actually accomplish oxide breakdown. If I find this value, I'm gonna look for it right here. I'm gonna try 1520. Say voltage. I'm gonna see if I can find the value for you guys. Um, so I know there are a few voltages touted online that it could be, but I know that the limit of Intel CPUs in terms of just pure voltage is quite high. Obviously, current is what makes it dangerous, but you're just never going to be hitting a high current and a insane voltage. It's just not practical. And type in 1.72 because I think that might come up with something. It does. Okay. So, all right. So as you can see, operating voltage for S and S refresh, which means the Raptor Lake and Raptor Lake refresh, which is obviously the hypothetically speaking the I9s in question, and the maximum voltage spec by Intel is 1.72. Now, obviously, you wouldn't be wanting to run 1.72 under any significant load, but hypothetically speaking, the oxide limit of, you could say the oxide breakdown sort of threshold of the CPU is roughly around this range. It's not going to be 1.45, 1.45 is a very, very reasonable voltage actually, within certain parameters obviously, but it's not really that crazy. 1.72 is the real danger zone, and it's a value you pretty much are not ever going to see, unless you really do mess things up yourself, or configure things very, very incorrectly, right? And here we have some arbitrary current limits, but I think it's important that we look at this value and just really appreciate how large this value is. All right, so the voltage limit, the voltage ceiling of the Intel 7 process right now is 1.72, at least in its current permutation is 1.72, which is it's a really staggering value. It's a really large value. So I just need you guys to understand how, I don't want to say preposterous, but just how absurd it would be to ascertain that the CPUs are certainly suffering oxide breakdown. It's just the limit is so high, and oxide breakdown is historically been known to it's historically been known to be such a devastating occurrence, at extreme voltage and such a sudden breakdown of the silicon that it just doesn't really make a lot of sense. And if if it was really the Intel 7 process and the actual silicon and perhaps the silicon involved with the cache, right, the L3 cache, the ring, then why have we not heard of any 12th gen CPU suffering oxide breakdown? It's a very interesting thing to think about, is if it really wasn't what I'm suggesting, which is that perhaps it is electromigration, perhaps these inconsistencies, and I just did demonstrated that there was still, I mean, if you want to argue and say that it's a valid argument if you want to bring forth the argument that perhaps Asus Gigabyte MSI not following the standard config with the 125 watt PL1, and you want to argue that them following the extreme config is something that they're doing incorrect on their part, and that I'm, you know, in the wrong for referencing Intel's documents and saying that there is a PL1 PL2 match on these i9s. I want you to consider the fact that Intel were supposedly consulted on these baseline profiles, and I don't think that Intel would have been too happy with Asus putting their name tag on a new setting imposed in the BIOS after this controversy. I don't think Intel would have been too happy with Asus going ahead and naming the profile Intel baseline and then using these values from the extreme config if they weren't to some degree pleased with it. I just find it hard to believe after all the controversy that Asus would go ahead and just not use these baseline values just on their own volition. This just after all of it, just I feel like that would be a bit absurd. And I mean, if Intel weren't consulted or just I just find that really hard to believe. But again, if you want some just evidence of there being inconsistencies, well, the 3900KS and 4900KS are right here. And to my knowledge, they're the only 150 watt S-line parts I know of. To my knowledge, at least. Maybe I'm wrong. If you know of a higher tier CPU, then bring it forth. Maybe there's a 13900K, I don't know, KZ, who knows. But as far as I know, the 3900KS and 4900KS are the premier CPUs in this, or at least in these two lines, and to my knowledge, the only two chips that could fit this specification right here. And as you can see in the product pages of both chips, I'm happy to reload the page for you. We're still at 150 and 253. And the baseline spec still calls for this on the documentation at least. So whether or not the non-KS parts are following an extreme config, which they might be, the KS parts, there is still inconsistency right here. On the product page. And all I'm trying to say is that perhaps there is some sort of I don't know, miscommunication within, I don't know. I'm just proposing. Perhaps there is some sort of internal I don't know, internal discussion happening, or maybe there was some sort of internal disagreement. Maybe there's a lot of miscommunication between Intel internally and motherboard vendors. Who knows? There could be a host of reasons why these inconsistencies exist, why vendors are allowed to make Intel baseline profile and then not use the baseline values and use the extreme config values. If I search extreme in this search bar, I'm curious as to how many times we see the word come up. So we see 12 instances in rare extreme conditions. Okay, not relevant. In extreme, not relevant. Extreme config, extreme config, extreme config, extreme config for the current values. Extreme config, current values again. extreme power is an optional extreme which allows better multi-core based on custom. So is an optional extreme power delivery spec. Headroom exists. So at no point does Intel say that using the extreme config will damage the chip or void the customer's warranty, or that it shouldn't be used unless you're willing to risk something or anything like that. At no point is there any mention of this config being a optional. Well, it's optional, but at no point is it mentioned that it's optional but also potentially harmful, and that customers should avoid it unless they're willing to risk something. At no point does it mention that there's risk involved or that there's some sort of warranty voiding or anything like that. So that's all I want to make clear in that circumstance. Now, again, I haven't observed my chip ever hitting some insane temperature and or insane power, power draw, and simultaneously being at some insane voltage because it's trying to boost to 5.8 in all cores, and I just don't see that happening, and I think I know why. Intel Adaptive Boost is an optional feature, and if you enable it and you end up in that situation, that is unfortunately your own fault, because IABT is nasty, and I have in the past enabled IABT a couple times on some older chips that I owned years ago, and just briefly going into Windows and just looking at how high the voltage gets, that definitely would be cause for concern. So if you decided to use IABT on your 13th gen i9, then yes, you'd be in trouble. But as far as I know, IABT is not enabled by default on any board. I owned a Gigabyte Tachyon last year. I've owned multiple Asus boards. My friend has an MSI board, and as far as I know, IABT is not enabled by default. So I'm just not sure exactly how individuals are hitting 1.5 volts at 300 watt loads. I just do not know how that's happening. I don't know how that's happening. I don't think it's possible. But if anyone wants to provide an example of their motherboard with default settings and no augmentations and no custom TVB settings and no custom IEBT settings or whatever, if anyone wants to bring forth an example of a motherboard at stock on a actual workable BIOS, not a broken a fringe broken BIOS, just a basic setup where their CPU with, like I have right now, unlimited settings, a multi-core enhancement enabled, just stock settings, but no power limits. So almost like how it used to be. If you want to use an older BIOS version that lacked the baseline settings and whatever, that's completely fine. But if you have an example of a CPU at stock with no TVB or IABT and settings enabled by the user, and just at stock settings, you can add XMP whatever, hitting 300 watts in a load at 1.5 or 1.6 volts or whatever, and just going completely insane and trying to boost some insane frequency. If you can show me that at stock, I'm very curious to see it, because I've never seen it. If it happens and I've never heard of it, then goodness, like I'd be very, very curious. That's the thing, because as far as I know, as the current increases, the voltage decreases, as far as I know. So that's all I'm saying. And I just demonstrated in this I believe it was this video. I might not have been. It might not. I might have made two videos. No, I made two videos. The video I recorded prior to this was a video where I showcased how games react to basically free power limits. And the long and short of it is that they don't really utilize the free range, the basic, like basically just open season on power. They don't use it. They just don't. And you could argue, well, there are certain games like UE5 games that do, and that's potentially true. That in a UE5 game you could definitely hit 300 watts for sure. But my counter to that would be you're probably going to be using 300 watts, but somewhere in the range of 1.2 to 1.25 volts at maximum from sense, because again, as far as I understand it, when current goes up, voltage goes down. And that's how LLC works, right? So, or well, I guess in this case it would be an internal, so IA, well, is it a AC/DC? Well, yeah, it's still a load line. So AC/DC, well, load line. That's how load line works. That's how VGroup works, right? It's as current goes up, voltage goes down. So at high power draws, you're not going to be at insanely high voltages. It's just not really how it works, is it? Like, I mean, it's just not really sensible. It's like, I mean, so yeah, I don't know. Like, if these CPUs really could boost to, like, for example, 5.8 at 1.5 volts and 300 watts, then I'm pretty sure they would in games. I mean, and certainly in a game like games like I was playing, like Far Cry 6 and Ghostwire and The Quarry and Assassin's Creed. I mean, surely in a game like that where you're only drawing like 100 amps, I mean, surely the CPU is going to hit like 1.45 volts at least. I mean, surely at least 1.45, like if not 1.5, 5 or 6. Like, why not? I mean, if it's only drawing 100 amps, why doesn't it draw 1.6 volts and just boost to like whatever, like 5.8 or something? Why? I mean, I don't see a reason why not. So yeah, I don't know. Curious stuff, man. I don't know.